Well done. If you have got this far, you have powered your way through to really tricky trig identities into trig equation questions. This one hopefully will seem like a little bit of a doddle once you have mastered those last two. This one is a wee bit simpler than the other two. Again, it just needs one other trig identity that we know. The thing you'll spot here, neither of these has a 2x in it. So this is why I've left this one to last, because the trig identity we're aiming for is a little less obvious because we don't have any 2x's appearing anywhere. We've got to think carefully, okay, well, what we're going to do instead. The thing that gives me a hint I can't solve it straight away, though, is the other factor that I mentioned. We've got a sine x and we've got a cos x. So that's a clue that solving straight from the start is probably not going to be the best strategy here. Well, certainly we can't even use that strategy. Now, this, once you've seen it, hopefully will make some sense. What I'm going to do is I'm going to move the 4 cos x to the other side. So I'm going to get sine x equals minus 4 cos x. Now, this would not be obvious to do if you've never seen an example like this, but once you've seen a few, this will become a bit more natural as a strategy when you've got a sine x and a cos x, but the angles are both x. There's no 2x's involved. Dealing with this, we can divide both sides by cos x. So that leaves me with a sine x over cos x equals minus 4. This is the magic bit, because sine x over cos x, this is an identity that you've learned, and it's one that you did in Nat 5, and we've covered again in higher. Sine x over cos x is the same as tan of x. And that's where our identity comes in, and that's where we've managed to simplify our equation from including sine x and cos x to just a single trig function that we can now work with. So that's your key step, is being able to do that. So anytime you see a sine x and a cos x with no double angles in there, so no 2x's involved, you're really usually aiming to get a tan x somewhere in your equation. Now we've got tan x, we're off because it's a standard trig equation. Because it's negative, if we are using our graph, we're doing the inverse of minus 4. That gives us, now be careful because you might not have spotted this detail, there's a lot of complexity here, but we're actually working in radians for this one. So just making sure our calculator's in radians mode when we do our inverse tan. So we get that, and that's not in range, so I'm not going to bother rounding it. Equally, you could have done your relative acute angle here if you are using a cast method, and you get the same thing but positive. 581,766. Good. Using our graph, well, the tan graph looks something like this. So remember, we're in radians, so that's pi. This is 2 pi. Our first angle is minus 1.32. That's somewhere over there. So our other angles are there and there. Bits of the graph that looks the same. Well, this is coming back by 1.32, so it's the same as coming back from pi by 1.32, and the same as coming back from 2 pi. So the angles we're interested in are pi minus 1.32, 581766, and the other one is 2 pi minus 1.32, 581766. So there's your two angles. You could have got those from cast in exactly the normal way. You've got a tan that's negative, so we're either there or there. That's 2 pi, so this one is 2 pi minus the relative acute angle. This one is pi, so this section here is pi minus the relative acute angle, giving us exactly those two things to work out. So working with that, we get 1.81577,498, which rounds nicely to 1.82 radians. and this one here, which is 4.95 and we'll round that to 4.96 radians. So we've got our two answers. I'm not probably going to bother writing them out this time because they're slightly more obvious. So we've got two answers and they're right at the end there. Not got quite so much complexity. So have a go at one of those for yourself. Again, this one, the big clue, we've got a sine and we've got a cos. No double angles in here, so we're probably going to aim to try and get a tan somewhere in our answer, in our equation. The other thing to watch out for, we are still in radians. So have a go at that one, pause the video, and I will run through the answer in just a moment. Great, hopefully you've had a go. So first step, I've moved the cos to the far side. Second step, I am dividing by the cos x. Now you'll see I've had to deal with 2 there. I've left it out the front. If you left it on the top of the fraction, that's okay. But the sine x over cos x bit is going to become a tan, which is why I've popped the 2 out the front, just to make it clearer when I do this, that becomes, I then divide both sides by 2, which gives me the half, and the sine x over cos x becomes a tan x. Done 2 steps in one there. But all I've done is I've changed the sine x over cos x bit to tan x, and I've moved the 2 across to this side by dividing by 2 on both sides. Now we can solve it. So we get tan to the minus 1 over half. That should give you 0.46. And that is one of our answers. The other one, we look at a graph, or we look at cast, and we get our other answer being 3.61 radians. And so there are our 2 solutions to that equation. Now, I know there's a lot in those 3 examples. There is a lot to take in. I haven't given you loads of questions, but hopefully enough. I've given you about 2 of each, just to get used to identifying which one you're working with and used to solving each one, running through those steps. I don't want you to be there for hours trying to solve hundreds of these, but I do want you to get used to using them a little bit as you work through.